This is questions 3, 5 and 7 from exercise 8.7 in New Concise Project Maths 3a. We're going to start with question 3. We should let the f of x equals x cubed plus 4x minus 2, and we then have to show that dy dx is going to be greater than 0 for all x, which is an element of R. So we're going to have to get our dy dx first. We're going to differentiate our function. So dy dx is going to be equal to 3x squared plus 4, like that. And we don't necessarily need to reason this to write this out any further with maths. We can actually just reason this from here. So x squared has to be a positive number, has to be bigger than 0, because you cannot square a number and get a negative number. It just won't work that way. Which means that if x squared is bigger than 0, then therefore 3x squared is definitely bigger than 0, because you're multiplying it by another positive number. And from there further, we can then say 3x squared plus 4 is then definitely bigger than 0. We're just piling it on bit by bit, saying we've definitely said that x squared is bigger than 0. Therefore, multiplying it by a positive number and adding another number on is definitely going to make dy dx larger than 0. And this will work for all values of x in this particular setup. Alright, let's take a look at question 5. In question 5, we have the curve y is equal to x squared minus 3x plus 5. And we have to show that that curve is increasing at the point 2, 3. Whenever we get a question like this where we're given a function and we're asked about either increasing or decreasing at given points, we're going to differentiate. And this is not going to be any different, so we're going to get our dy dx, and that's going to be 2x minus 3. And dy dx is a way of finding the slope of a tangent to a curve at a given value of x. In this case, the given value of x is going to be 2, because it's coming from the point 2, 3. So we're going to say when x equals 2, so we're going to get 2 times 2 minus 3, which is equal to 4 minus 3, it's equal to 1. And since 1 is greater than 0, we can therefore say that y is increasing. At point 2, 3. If the number we got at the end, instead of 1, if we'd got a negative number, then that graph would be decreasing at that point. But we found what we were looking for. We found a positive number, which shows that the graph is increasing at that point. Alright, let's take a look at question 7 now. An artificial ski slope is described by the function h equals 165 minus 120s plus 60x squared minus 10s cubed, where s is the horizontal distance and h is the height of the slope. We have to show that the slope is all downhill. So, to do that, the first thing we're going to do is we're going to differentiate. We're going to find dh ds. And that's going to be equal to minus 120 plus 120 s squared, not squared, my mistake, forgive me, 120s minus 30s squared. And we're going to rewrite that in descending powers of s to make this a little bit easier for ourselves. So minus 30s squared plus 120s minus 120. And now we're going to factor out minus 30. And inside we're going to have s squared minus 4s plus 4, like that. And then what we have inside is a quadratic trinomial, which we can also factorize. So we're going to have minus 30, and it's going to be s minus 2 times s minus 2, which means our full factorization of this is going to be minus 30. Try to write that a bit neater. Minus 30 times s minus 2 squared. Okay, so that's our expression for dHds factorized. And the reason we factorize this is because from here we can go about reasoning out why the slope is all downhill. For the slope to be all downhill, it would mean that the function is going to have the dHds is going to have a negative slope for any value of s. And what we look at here is we can say that s minus 2 all squared is definitely larger than 0. Because if you square any expression or any number, you're going to get a number that is larger than 0. So we can say from that therefore minus 30 times s minus 2 all squared is going to be less than 0. Because we've multiplied it by a negative number, which will make it smaller than 0 now. So therefore we can say that dHds is decreasing for all s which means that the slope is all downhill. There's no uphill parts of the slope. And that is that.